This example shows you another type of design problem. It's given a lot of information regarding the material properties and allowable stress level factor of safety. Then you're requested to design the size, the dimension of a structural element. Okay, these two axial members are connected by two plates as shown in this figure, and 8 bolts. Okay, double shear. Again, this double shear connection. Then determine the allowable minimum diameter of the bolts if a factor of safety is 1.2. And note that this double shear connection and yield stress, load P, have both been given. Okay, so we're requested to determine the minimum diameter of the bolts. So how can we do this? We have to estimate the minimum area, right? If we know the area, the load carrying area, then we can calculate the diameter, right? So we should determine the load carrying area. The load carrying A. So what is this? Right. And also note that we have 4 bolts. Right. We have 4 bolts and double shear. Right. So that means the A equals pi over 4 d squared times 4 times 2, right? Or 2 pi d squared, the same as the previous example. Okay, so based on this, the D minimum can be calculated from A minimum over 2 pi. Right, so this is the equation we just derived to solve this minimum D. Right, so to achieve this, we will need to find out the minimum area. Right, so what is the minimum area? So this will request us to determine the V and tau max. Right, since this thing equals the shear force over the maximum or allowable shear stress. Then just what is the V? What is V? V equals P. Again, we have been dealing with this kind of problem many times. Right? This is you should quickly realize that V equals P. Right? Then how about tau max? Tau max can be just calculated from yielding stress over factor of safety. Right? So everything has been clear. So first step, tau max equals yield stress over factor of safety. That is given here 220 MPa over 1.2. Well, that is 183.3 MPa. Then the second step, V equals P. Well, V equals P, that is 470 kilonewton. And the minimum area will be calculated from V over tau max. That is 470,000 Newton over 183.3 MPa. Right, so the result, the unit of the result will be square millimeter. Right, so we'll get 2,564 square millimeter. Then the last step, the D, minimum D, can be calculated from 2564 over 2 pi. Right, that is 20.2 millimeter. So this is our minimum diameter of the bolt determined from this calculation. So your design result will be, make sure that the true diameter of the bolt selected in this connection should not be smaller than the minimum D.